Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P2121 indicates an issue with the Accelerator Pedal Position APP Sensor A, specifically labeled TP Sensor D, being out of its expected operational range. This sensor is crucial for ensuring that the vehicle's electronic throttle control system receives correct input regarding the accelerator pedal's position. When the APP sensor fails or sends an incorrect signal, it can lead to performance issues, reduced throttle response, or even a complete engine shutoff, posing a potential safety risk. This code specifically indicates that the voltage from the APP sensor is either below 0.66 volts or above 4.9 volts, which signifies abnormal behavior. The APP sensor is typically located on the accelerator pedal assembly in the driver's footwell of the Honda CRV. Proper diagnosis involves validating the APP's voltage signal through a Honda Diagnostic System, HDS, prior to moving forward with troubleshooting efforts. Having a clear understanding of both the location and function of the APP sensor is vital for accurate diagnostics and repairs. The APP sensor A is responsible for sending voltage signals that represent the position of the accelerator pedal to the powertrain control module, PCM. This information allows the PCM to manage the engine's throttle response effectively, optimizing performance and emissions. Located on the accelerator pedal assembly in the footwell, the APP sensor outputs signals within specific voltage thresholds. A typical operational range should ideally be between 0.66 volts and 4.9 volts. When the voltage falls below or rises above these thresholds, the PCM recognizes this deviation as a fault, triggering the DTC P2121. The effective operation of this sensor is critical because any irregularity can lead to loss of acceleration, engine stalling, or even unintended acceleration in severe cases. Several factors can cause the DTC P2121 to trigger, each requiring careful consideration during diagnostics. One primary cause is a faulty APP sensor, which may not provide accurate voltage readings. Another possibility includes wiring issues, such as short circuits or connections that may be damaged, either of which can lead to incorrect voltage signals. Poor connections at the APP sensor or the PCM can also cause intermittent communication problems, further complicating the situation. Before concluding that the APP sensor is at fault, it's essential to methodically check for these potential issues to ensure that a component replacement is necessary and will resolve the error. Drivers experiencing issues related to DTC P2121 may notice several symptoms linked to throttle control problems. One common symptom is reduced throttle response, where the vehicle hesitates or fails to accelerate as expected when the pedal is pressed. In more severe cases, engine stalling may occur, indicating that the PCM is unable to manage engine power effectively due to incorrect input from the APP sensor. Furthermore, drivers could observe unusual acceleration behavior, such as unintended acceleration or failure to increase speed promptly. Each of these symptoms poses potential safety risks, which makes timely diagnostics and repair crucial to vehicle functionality. Begin troubleshooting DTC P2121 by turning the vehicle to the on mode and utilizing the Honda Diagnostic System HDS. The first step includes checking the APP Sensor A output. It is essential to monitor the signal and verify if the current value falls below 0.66 volts. If it does, the failure has been confirmed, allowing you to proceed to step 3 in the diagnostics process. If the voltage reading is above this threshold, move on to step 2 to continue the troubleshooting process. Accurate voltage measurement is critical since it indicates whether the APP sensor is functioning correctly. In this second step, check the APP sensor A output again while ensuring that your vehicle is still in the on mode. This time, the focus is to see if the output voltage exceeds 4.9 volts. If it does, you confirm another failure and should proceed to step 8. However, if you find that the voltage readings are within a normal range, this suggests that there may be intermittent failure due to poor connections or loose terminals either at the APP sensor or the PCM. In such a case, take extra time to inspect these areas for possible issues or integrity problems within the electrical connections. It is essential to reproduce any recorded DTC conditions to effectively diagnose intermittent faults. For step 3, begin by turning the vehicle to the off position to safely disconnect the APP sensor's 6P connector. After ensuring the disconnection, turn the vehicle back to the on mode to continue diagnostics. This time, you will measure the voltage between specified test points of the APP sensor 6P connector. You are particularly checking between female terminals number 4 and number 5. The expected reading should be about 5.0 volts. If you achieve this result, it indicates that you are on the right track. If not, you may then need to investigate further for possible wiring issues or faults in the APP sensor assembly. In this step, turn off the vehicle once more before jumping the SCS service check mode line with the HDS. Wait for more than 1 minute to ensure a stable reading. Disconnect the PCM connector A, 51P, to measure continuity. This process entails checking for a potential short in the APS1 wire by examining the relationship between test points identified on the APP sensor connector and body ground. If continuity exists, it suggests a short circuit scenario in the APS1 line, and repair will be necessary at the cable connection between the PCM and the APP sensor. If no continuity is noted, you will need to advance to the next step, confirming if further issues exist. Moving on to step 5, you'll follow the prior continuity tests by connecting terminals A and B with a jumper wire to diagnose an open wire in the APS1 line. This action involves using a jumper wire to ground the APP sensor 6P connector and checking for continuity again between 2 designated test points. If continuity is confirmed this time, the APS1 wire is functional, allowing you to proceed to the next troubleshooting steps. However, if continuity is not present, it indicates a break or open circuit in the APS1 wire, necessitating repair between the PCM and the APP sensor to restore full functionality. For troubleshooting step 6, you'll first need to carefully remove the jumper wire connected to the APP sensor 6P connector. Next, re-establish the connection of the PCM connector A, 51P, before jumping terminals A and B again. Once that is completed, exit the SCS mode using the HDS and proceed to measure the APP sensor outputs while the vehicle is in the on mode. Again, you're checking if the voltage signal is less than 0.66 volts. If this condition persists, it would indicate a possible internal circuit failure in the PCM, and you may need to refer to authorized service information or consider substituting with a known good PCM. If the readings return to normal, then replacing the accelerator pedal module would be the prudent next step. In step 7, you'll begin troubleshooting the VCC4 line, essential for supplying power to the APP sensor. Again, turn off the vehicle and jump the SCS line as done previously. Then disconnect the PCM connector A, 51P. Connect terminals A and B with a jumper wire to assess whether the line between the tapped areas shows continuity. If continuity is confirmed while maintaining the conditions outlined, then the VCC4 wire is functioning correctly. At this point, you should look for authorized service information or substitute with a known good PCM to continue diagnostics. If there is no continuity, an open circuit in the VCC4 wire will need to be repaired to restore proper signal functionality. As you progress to Step 8, begin by disconnecting the APP sensor 6P connector and ensuring that the vehicle is powered to the on mode. This step is to measure voltage between the respective test points identified in the APP sensor 6P connector. An optimal reading should show approximately 5.0 volts. If this voltage is achieved, it indicates that the APP sensor has failed and will need to be replaced with a new accelerator pedal module. If the voltage does not reflect this reading, you should further inspect for possible issues before continuing to the next troubleshooting step. In the final troubleshooting step, verify the SG4 line by again ensuring the vehicle is off and the SCS line has been jumped for the recommended weight. Once ready, check the continuity again with a jumper wire connected between the APP sensor 6P connector and body ground. Following this measurement, you would again ensure the integrity between test points on the PCM. If continuity is established, then the SG4 wire is fine, indicating it is necessary to assess for authorized service information or replace the PCM if needed. However, if there is no continuity, you must repair the open circuit within the SG4 wire between the PCM and the APP sensor, thus resolving the DTC P2121 issue. After completing all necessary repairs related to DTC P2121, it is vital to clear all Diagnostic Trouble Codes, DTCs, from the vehicle's system. This allows for accurate monitoring post-repair. Following the clearing of codes, perform a thorough road test to ensure that the vehicle operates as intended. During this road test, closely monitor the throttle response to confirm it aligns with driver commands and there are no recurrences of the previously experienced symptoms. This step is essential not only to verify repair success, but also to provide reassurance that the vehicle is reliable and safe for normal operation. To help avoid future issues related to DTC P2121, it's crucial to implement preventive maintenance strategies. Regular inspections of cables and wire harnesses associated with the APP sensor can detect wear or damage before they lead to functional problems. Ensure that all wiring is secured and free from physical damage due to environmental factors or mechanical interference. Additionally, timely checks of the APP sensor and its operational function can preemptively identify any abnormalities that may develop over time. Regular maintenance practices not only prolong the life of vehicle components, but also enhance overall driving safety. In summary, Diagnostic Trouble Code P2121 highlights an issue with the APP sensor A, which is critical for regulating throttle response in Honda CRV models from 2017 to 2022. The diagnostic process involves multiple steps to accurately determine the root cause. Whether it be the APP sensor itself, wiring issues, or electronic faults within the PCM. A careful stepwise approach is necessary to ensure systematic fault evaluation. Furthermore, ongoing preventive maintenance can significantly aid in limiting future occurrences of this issue, resulting in safe and reliable vehicle performance. Understanding the sensor's role and implementing correct diagnostic practices can enhance both the operational efficiency and safety of the vehicle. Please like and subscribe to the channel. See you next time.